All right, this is the solution video for Unit 8 review, problem number 5. All right, so find the area of the region bounded by y equals x squared and x equals 1/8 y squared using a dx cut, using a dy cut. All right, so first of all, we need to start off with a graph. All right, what is y equals x squared? Well, y equals x squared would be a graph that looks like that, right? And then x equals 1/8 y squared. Well, that would be a sideways parabola facing to the right, and that is kind of wider than normal, right? But this would basically be our graph, right? So here is our region of interest, right? Now it's just an area problem. Now, initially it says to use a dx cut. So that means, remember, dx cut means we need our equations in y equals form. So we have y equals x squared, and then we have y equals what? Well, we would multiply by 8 and then square root. So plus or minus the square root of 8x, right? So it's important to note that this sideways parabola, this is the positive square root of 8x, and then this is the negative square root of 8x, right? So I actually don't even care about the negative part. I only care about the positive part. And then this one is the x squared, right? So if I'm going to find the area, I'm going to integrate the upper boundary of a dx, right? So the upper boundary of the dx would be the positive root 8x minus the lower boundary, which is the x squared, and I'm going to integrate with respect to x. Now, remember, okay, we're integrating from left to right. So I know where these two intersect at 0, 0, right? Or I should know that, right? But how do I know what this one is? Well, remember, this is when the two things are equal, right? So we could do this a couple different ways, but basically, right, if y is equal to x squared, right, then I could put in this x squared for y over here, right? And so I get that x is equal to 1/8 x squared squared, right? And so I could solve this, right? I'm going to have 0, and then I'm going to have 1/8 x to the fourth minus x. I'm going to factor out an x, and I have 1/8 x cubed minus 1, all right, equals 0. So x equals 0, which we already knew. And then 1/8 x cubed minus 1 equals 0. So I'm going to add 1 and then multiply by 8. So x cubed equals 8. And so x equals 2, right? And so that means this is at 2 comma what? Well, if x is 2, then y is 4, right? So I get what? I'm going to integrate from left to right, so 0 to 2. All right. And so now that would be uh, the setup for this, right? Okay. But we are going to continue, right? The directions here. Let me just look at those directions, right? It doesn't say, it just says sorry, I'm in the wrong section. All right. It does say to find the area, right? So it doesn't say set up only, right? So we actually need to calculate this. All right. So now in order to integrate, we're going to need two separate integrals, right? So I'm going to integrate the first one, the square root of 8x. Okay. Now I could rewrite this, but I'm just going to do um, a u substitution, right? So u equals 8x. So that means my integral is going to be of u to the 1/2 du, right? Now remember, du then is 8 dx, so I need a 1/8 on the outside. All right, but then also my limits need to go from 0 to 16, right? 2 times 8. All right, and so I have 1/8 integral of u to the 1/2 would be u to the 3/2 over 3/2, and then I'm going to evaluate that from 0 to 16. All right, then I have minus, and I could just integrate this. This is just x cubed over 3, and I'm going to integrate that from 0 to 2. So minus x cubed over 3 from 0 to 2. All right, so this is the dx cut. All right. So if I'm dividing by 3/2, that's like multiplying by 2/3, right? So the 2 and the 8 reduce, leaving me with 4. So this is really just 1/12. And then I have u to the 3/2. So 16 to the 3/2 minus 1/12, 0 to the 3/2, right? That's the first part. Then I have minus, and now I'm just going to do 2 cubed over 3, not 8, sorry. 2 cubed over 3 minus 0 cubed over 3. All right, so 16 to the 3/2. That means the square root of 16, which is 4, cubed, right? So that's going to be 64. 4 times 4 times 4. So 64 twelfths minus, and this would just be 0, right? And then I have minus 8 thirds here, and then I have plus 0, right? But those go away, right? And so now I have 64 twelfths, right? So 64 is divisible by 4, and so is 12, right? So this would be 16 thirds. So 16 thirds minus 8 thirds is 8 thirds. So my answer is 8 thirds, of course. All right, now I want to use a dy cut. All right, so let's go ahead. I'll change color so it's a little bit easier to see. All right, so now a dy cut. All right, so now that means I need my equations in x equals form. So I have the first one, x equals 1/8 y squared, but now I need the other one, x equals plus or minus the square root of y. All right, now remember, if I'm using this, all right, this right hand, right, is actually just the positive root y, right? And then this one here, right, is what? Well, it's the 1/8 y squared, right? And so now I'm going to be integrating the upper boundary, or in this case, the right hand boundary of the dy, which is the positive root y, minus the left hand boundary, which is the 1/8 y squared, right? And we're going to integrate with respect to y, and then we're going to integrate from lowest to highest, which would be 0 to 4, right? And so that is my setup, but now we need to carry this out. Now, this one's a little easier. We don't need to use substitution. Integral of the square root of y, remember that's like y to the 1/2, so that would be y to the 3/2 over 3/2, and then minus 1/8, and this would become y to the third over 3. And then we're going to evaluate from 0 to 4. All right. And so now this becomes 2/3 y to the 3/2. So this is going to be 4 to the 3/2, right? And then minus 1/8. That's really just 1/24 y, which is 4 cubed, right? All of that minus 0 to the 3/2, right? Sorry, 2/3 times 0 to the 3/2, and then minus 1/24 0 cubed, right? Of course, the whole second part is just 0, right? So now here I have 4 to the 3/2. So what does that mean? It means square root of 4, which is 2 cubed, right? So this would be 2 times 8 is 16 thirds minus 4 cubed is 64, right? But I could take one of those here, make this 6. So it'd really just be 4 squared. So it'd be 16 over 6, which is reducible to be 8 thirds. And so 16 thirds minus 8 thirds is 8 thirds. Now, these two answers are the same, right? Why? Because they're just finding the area, right? So they should be the same. All right, but that is problem number 5.